Hi everyone, this is Neel Raithatha, also known as the Wax Whisperer. Thank you for joining me in my latest video. We have here a patient who primarily attended reporting a blocked left ear, and they have to attend every 12 to 18 months. And they always suffer from this really dry wax and keratin, so dead skin. And once I remove this blockage, you'll see that the midsection of the ear canal is somewhat narrowed. And it would appear that this wax and dry skin, it's trying to naturally migrate out of the ear, but it gets trapped at this narrow juncture within the ear canal. So because it's really dry and there's a lot of skin adhesions, I'm just trying to remove this mechanically using ear hook, Jobson Horn and Forceps. I'm just getting the hook in behind. It's really strongly adhered. Another approach you could do is put some olive oil spray in the ear and try to perform microsuction, but because it's so dry and dense, with the olive oil it may soften the more lateral surface of the wax, but this extends quite deep, and I just felt using dry instruments would be a bit more effective here. And just trying to get over the top, in and behind, and I'm just trying to leverage it out. I think eventually I used the forceps and I managed to grip it from the base of the plug and then lift it up and give it a little wriggle. So I'm just trying to get it into the core here. And the wax is just slightly separating. So there's a bit of an opening at the roof of the ear canal. So this patient's ear canal is what I call elongated. Now, all of our ear canals should be oval in shape. They shouldn't be round and cylindrical. So the height of the ear canal is, on average, it does vary from obviously individual to individual, and also at different aspects within the ear canal, different parts. But if you say between 0.7 and 0.9 millimeters, so it's just under 1 mil, and then the width, again, it can vary, but if you say between 0.5 and 0.7, so you get this natural egg shape, or rugby ball shape, or American football shape. I would say this patient's ear canal, the height is generally a bit more greater than the width than the norm. So it gives it's this elongated, stretched appearance. So I've got the majority of the plug out. You can just see how dry that is. It's quite matted as well. So I'm just using a little ear hook, a little metal port. So we've got to be careful because we're quite deep into the ear. We just don't want to make contact with the canal wall with the hook, because that would be rather uncomfortable for the patient. Just going to go back in. I'm going to get the bottom jaw underneath, lift it up. I'm going to get a good purchase now, and then you can see all that dead skin just pries away off the front part of the ear canal. So this is a bit further and deeper into the ear. And again, just going to be careful because we are quite deep now. I've just got to the posterior part of the ear canal, the back section, managed to find a good grip here, and you can just see, it looks like a bird's nest, this. So earwax has three primary ingredients, and the most common is dead skin cells. So the ear canal and the eardrum is lined with skin, and as the skin dies and sheds, it's replaced by another layer of skin, and that dead skin slowly makes its way outside of the ear, almost like a conveyor belt. And as it does, all the skin cells that were once attached to one another begin to descale, so they begin to flake and separate. And these dead skin cells mix with hairs in the ear, and it provides a scaffolding for a wax plug. And then the inside of this scaffolding is filled with sebum, which is a oily lipid secretion also found in our scalp. So they're secreted by the sebaceous glands, and the sebaceous glands are attached to the hair follicles, and the hair follicles, where you probably see some of the hairs at the entrance, they're on the outer third of the ear canal, the cartilaginous portion. And sebum is made up of organic compounds such as alcohol, squalene, cholesterols, long chains of saturated and unsaturated fatty acids, esters. These all form an amalgamate to form sebum, so this oily lipid secretion. And it's quite viscous, so it's quite thick. And then you've also got cerumen, which is another name given to an oily sweat that we also found in our armpits and inner groin region. And cerumen is secreted by modified sweat glands called apocrine glands. And so it's different to the sweat you may find on your brow, which is more water and salt based. Cerumen is more an oily sweat, and it can be quite odorous. That's less viscous than sebum. And how viscous your the oily sweat is dependent upon one singular gene mutation. So there's a gene called the ABCC11 gene, and it has two variations caused by a single mutation. So if you have one dominant guanine allele, it means that you have a functioning ABCC11 gene. And then if you have two homozygous recessive alleles, adenine alleles, so these are nucleotides, and you then get a non-functioning ABCC11 gene. So what the ABCC11 gene does, it codes for a protein that helps to transport lipid-soluble, so molecules that dissolve in lipid secretions, in oils, across between cells and also within cells themselves. And when you've got this functioning gene within the ceruminous glands, and this gene is exclusive to the ceruminous glands, it transports these molecules, these additional molecules, these lipid-soluble molecules, and they pair up in pairs. And when they pair up, they're either naturally odorous, or when eventually these molecules, these pairs of molecules, are pumped up at the ceruminous glands, up the pores to the surface of the ear canal, bacteria that reside on the skin on the ear canal itself, they feed on these pairs of lipid soluble molecules, and then the bacteria themselves excrete odorous smells in response. So it's almost their byproduct. So either these additional molecules that are found within the oily sweat are odorous by default, or they become odorous once bacteria feed on it. And if you've got these additional molecules within your ceruminous glands, the oily sweat becomes even less viscous, so it becomes more dilute, more watery, less thick, and then you get wet earwax. And so if ever you've got wet earwax, there's a genetic link to whether the oily sweat that you produce under your armpit is odorous or not. So most of the population does have this genetic, this functional ABCC1 gene, especially the Western cultures. Now, in the Far East, they typically have a non-functioning ABCC11 gene, so that their ceruminous glands doesn't transport these additional lipid-soluble molecules in between cells and within cells themselves. So they have dry wax and they have a non-odorous body odor. So, should I say non-odorous sweat under armpits. So something new there. So if you're on Who Wants to Be a Millionaire and you get asked this question, hopefully you can donate some of the prize money to me. Now, just going to pluck that hair out. I know some of you guys are going to go crazy if I don't. So yeah, I managed to clear both ears. Nice healthy eardrum. And you're going to see all the debris there, all the dry skin. You can just see how dry it is. All the whitish elements are more recent dead skin, and the darker bits are dead keratin that's been there for longer. And guys, I'm just going to leave you with this.